So let's get started with image scanning using Clair. Our presenter today is Dustin Van Buskirk. He is our Senior Solutions Architect at Codefresh, and he has over 7 years of DevOps experience in DevOps-related roles. And he's passionate about helping engineers build fast and automating all things.
Okay, so today I'm just going to kind of walk through a few different things, kind of an end-to-end to help us get Clair scans set up inside of our Codefresh pipelines. We'll talk about installing Clair. It's a Helm chart. It can be installed into your Helm repository with Codefresh, and then we can have a Helm release around that that's going to allow us to continually update the Clair installation. The next thing we're going to do is we're going to step through adding a small bit of YAML to one of our Codefresh pipelines to enable scanning of our Docker image that we're working on. And then we'll set up a storage integration because it's kind of critical to be able to store the reports that are generated by the system. We could just use it as a blocker if we want to as well in our pipeline. And then finally, we can go ahead and upload those Clair reports so that they're stored alongside of our builds and also available to our users. And I'll kind of show you how a user can trace back to those pretty easily from what's running in our production systems. Okay, let's go ahead and go to the next slide here. Security. It's pretty important to start with some type of security. There's a lot of different vendors out there today that support different aspects of security as far as, whether or not you're going to secure your Docker images, your libraries, your static code, or you're going to look at something like protecting your runtime from intrusion. There's a bunch of different ways to do that. But anything that's going to be of low cost to you and also not a big burden on your engineering team should just be a given. One of the things with this step is it's really going to take as long to report back to your engineering team as the amount of vulnerabilities that are disclosed in the report. Another thing that's really helpful out of the report that you'll see is we'll also be able to remediate a lot of these vulnerabilities because there's steps to remediation back at the vulnerability databases. So it'll tell you, this is the version that you need to update to in order to support this. Of course, any of those updates, those libraries have to go back to engineering, and you're going to want to confirm, the application's running correctly after the changes. You're going to want to confirm the vulnerability has been fixed. And that kind of gets us to this next really important point is that the earlier we fix these, the less cost there is. So there has been a recent big data breach. There's a lawsuit in play right now. It's a really popular hotel chain. And their data breach, we don't know exactly what the vulnerability information is, what happened, but I'm pretty sure they're looking at security today. If they aren't doing something, outside, the Clair or some type of open source or some type of low cost solution, they're probably looking into high cost solutions now to help better protect. So anything that we can do here and give feedback to our engineers, fix before it's ever pushed out to development or production, that's going to be the best case for our company, both money wise, not just for the expense of engineering resources, but also for the expense of the entire organization as a whole, because there could be expenses later on down the line that aren't involved in the software development lifecycle. So today we're just going to set up some minimal steps to help you test this, to help you get a report back to your engineering team, and kind of walk you through that step and having that inside of your lifecycle going forward inside of your CI. Okay, and next on my screen here. So where does it kind of fit? Open source project. It's really simple vulnerability scanning. It's going to scan all our libraries and dependencies inside of our Docker image. So, if you're using something like say a .NET Core, you're bringing in a lot of dependent packages out there from open source solutions. You'll get some vulnerabilities there. It's just going to be a given. Of course, those are normally addressed and they're fixed, and it's about upgrading, whenever there's a fix available as well. So there's some different toggles, et cetera, on the report to help you get that data. Then also we want to be able to not just scan what we currently have and continually scan it and remediate. We're going to want to prevent vulnerabilities from being introduced. As we start looking at, adding an additional feature to our core platform, that's going to probably introduce new libraries and dependencies outside of what we already have in the core platform. Those can be, we can prevent those vulnerabilities and maybe even talk about remediating those by recreating that code internally and not have that vulnerability brought in from the public. Clair scans in the pipeline. So we really want to scan our Docker images And we can also, at the time of the scan, determine if we want to set a threshold on that scan. So depending on the severity threshold, it could be high, critical, medium, we can actually enforce that threshold on our pipeline and start failing builds to prevent high and critical vulnerabilities from reaching our platform in the first place. Get that build failure back into the hands of the developer and let them know what's going on. Clair reports, so in addition to not just annotating the metadata on the Docker image, I'll show you how that's all done so that your users can see really quickly what are the vulnerability counts for each different severity threshold or severity level. We'll also have a really nice HTML report to look at the end so that we can hand that off to our security team or even back to our developers so they can have some actionable items from that. And then finally, we're going to store these reports long-term for all the different builds that are in progress. So we'll kind of walk through a little bit of the setup of how Codefresh can store these reports for you at build time. And we'll walk through the storage integration there that we have and how these are attached onto the build system and how you can trace back from like what is running in my production cluster all the way back to my build information, my commit information, and then of course my security report. All right, so first we'll kind of get started with the Clair Helm chart. They do provide a Helm chart to help us install Clair, and we can walk that Clair installation now. There's just a few pieces of information we kind of have to change in order to adapt it into our situation. The original Helm chart was built with 3.0 in mind, but that's still not in a fully released state. So I revert back to a 2.0, and also that entails some changes to like the Docker image repository and the Docker image thing and the Docker image tag. And then also we have to make some updates to Ingress. In my situation, I'm actually using from the internet. Again, all my projects are open source. They're not critical. You can actually close that down. It originally ships to the cluster IP, but in my case, I'm doing a load balancer so that I can automatically connect to that from anywhere. That's not the most secure way of doing things, obviously, is going through the load balancer. But I'll show you those changes just so you can understand how to make them. And then we'll upload that Helm chart. Well, sorry, it'll already be uploaded into our repository for Helm inside of Codefresh, and we'll install from there. All right, so YAML step for Clair scan. This is the minimal step. Now, there is some other requirements. We'll kind of talk about those. But outside of this, it's the URL to talk to Clair. Docker registry username, Docker registry password. So it's a very minimal set of actually steps that you have to import into your Codefresh pipeline. And oops, sorry, skip right past that. So, and then we'll also talk about what the annotations look like. You'll see here that we get a count of all our vulnerabilities, the actual severity level, and a nice little Clair report link back for our Docker image page. So this is an image UI that sits over the top of our Docker registry. Gives you some insight into the metadata, the annotations on that Docker image. We'll walk through kind of setting up a storage integration. I already have one set up, but I'll just kind of show you that process to set up like an S3 bucket to use to store your reports. Now, these aren't just the Clair reports. These could be your Mocha reports. We support a Lure framework, for example, and you can upload multiple different types of reports and just have those in a Lure format, and we can visualize all those reports in one place. I won't be showing you that, but I'll be showing you how to do a simple step to just upload this HTML report. Okay, that's kind of covered on that other slide. And this is what the step looks like. Really simple. We have a Docker reporting step. We give it the directory where we're going to be storing our reports, and then we give it the actual index file. So if we had a bunch of reports in here, say in the case of Mocha, and there was like a Mocha HTML that allows us to dig into all the different reports that we've generated, kind of like as an index page. That's where we can employ this index file. If we don't, then we can just link directly to the HTML file, and we'll be able to visualize that from the pipeline. Test reporting, again, all the different builds are going to report that. You'll have the view log button and the test report button. I'll show you that in the demo. And this is what the actual end product will look like when you get your Clair report. So you'll have information on when it's going to be able to fix. You even have a toggable only show fixed option here, so you can fix whatever has already been fixed as far as been updated in that library. And they know that they fixed it in a specific version. You can get that version and start testing on that. So you'll get that feedback pretty quickly. Other information, including a link back to the original CVE. Okay, demo time. Let's go ahead and get started. All right, so really quick, this is the step that we're going to be importing. You can see here there is a lot of different options that we could do here. We support, Docker registry auth tokens, etc. for ECR. Of course, we support our own Docker registry that's built inside of Codefresh. That's what I'm going to be demoing today. And the severity threshold is this threshold that we could set on each different pipeline and just have a flag for, high, critical, etc. And if that threshold is met, it's going to actually fail that build. So we can prevent those high vulnerabilities from getting to production, or even medium vulnerabilities, depending on what our security team has set forth. So what this looks like is I have this pipeline here inside of Codefresh for my worker Docker image. This is part of an example voting application. Inside of Codefresh here, I have everything set up, general settings, runtime, environment, variables, etc. The real thing I'm going to be focusing on is the YAML portion of this. The YAML portion is where we're getting into the actual building of the Docker image, and we're going to get into the step to check Clair and to also archive this report. So you can see here, this is very similar. The Docker registry, et cetera, those are going to be set at a different variable level than the actual pipeline itself. There is a pipeline variable level. There's a global level that's set across all the pipelines for a specific repository in Codefresh. And then there's actually, we could take an import either as plain text or encrypted text into our pipeline from the account level. So we can just drag down and drop that and put in those credentials. So I'll show you that really quick. So if we wanted to just define this in one place, for example, I can drag down from this import share configuration, grab like my Clair settings and import those automatically. In my case, I've set them at the global level, and that's under this general tab here. You can see a bunch of information. All right, so back to this pipeline here for worker. I'm going to go ahead and skip this part here. We'll come back to it here in just a second. I'm going to go ahead and say that that's the step that we need to set up. And then right now we need to set up some of the precursor of this, which is going to be installing Clair. So with Clair, they have a Helm chart already available to you. You can see here, I'm actually using the Helm chart. I pulled down their open source project, so they are open source, and I've made some minor changes to the Helm chart. Again, it comes kind of into these flags down here are being changed inside the Helm chart of the repository because they have a Clair repository that has the latest that's using 3.0, which hasn't been officially released, and then you have a 2.0 version. So I had to change the repository, the tag. I elected to change the type on the service for load balancer so that I can get an externally facing IP from my Kubernetes cluster so I can connect externally. A lot of the times you're going to keep that internal IP. The scan does by default grab your Docker image, scan your Docker image, then delete the Docker image from the server for Clair. But sometimes you may actually want to leave that in place. There is an option to set up Clair to create notifications back to your users. So it can store a Docker image long-term, and you can set up a scanning cadence on that Docker image so that you're continually scanning it like on maybe a nightly basis. So if there ever is any vulnerability exposed out there and you're not running this through CI on a daily basis, it might be a really good idea to get that vulnerability information about that Docker image running in your production space back to your users, and that's a good way to do that through that notification process. So once I do have all this edited, I've actually uploaded this into my Helm repository with Codefresh. So with Codefresh, we have 5 Helm repositories. I'm just using this default one that's set up automatically when I created my account. Here you can see the Helm chart that's been sent up to the repository. From here, I can install this right into my Kubernetes cluster. So here I'm going to select my sales demo cluster. Actually, sorry, I almost forgot. I need to create a namespace for this. So I'm going to create a namespace in my Kubernetes cluster here. So let's go ahead and add a namespace. Cluster production first. Let's go ahead and add a security tooling namespace here. So I got a security tool namespace. All right. So this is the namespace I'm going to install this Clair into. So it's separated off from everything else. For different purposes, I might want to actually, set that aside from my production instance or even my develop instance. I might want to set that in its own security space. Now I'm going to go ahead and install. All right. So going through the install process with Codefresh, with the Helm charts, I can install those easily right into any of my clusters that are connected to Codefresh. We support all the different clusters out there, AKS, EKS, GKE, your own data center, for example. Here, I'm going to go ahead and select my security tools namespace. And I could have edited those default chart values here instead of editing them back into my server. I decided not to. You can see we have an inline editor here that we can edit through these. We could even override over the top of the values file with a values file that we've placed inside of Codefresh. So we have the option stored YAML and secret YAML inside of Codefresh that we can just drag down this option and overwrite those values. I'm going to click install here, and we'll start installing our release. So as soon as this installs, and I already have it pre-installed, just forewarning you, it takes about 15 to 20 minutes, depending on the infrastructure, to download all the CVEs from the vulnerability databases that are out there. It's not pre-seeded. The way Clair works is it starts up, connects out, and downloads all the CVEs from the databases into its own Postgres database. And then, of course, there's a cadence around that updating, like on a per nightly basis. So you can see here, we've actually started Postgres database, and we started Clair server. If I come back into Helm, I can actually manage this now as one of my releases. So my sales production cluster, I have this new Clair install. It's been just created a few seconds ago for me. All right, so that's the installation of Clair. Again, you'll have to wait 15 to 20 minutes to seed the database, so you actually have vulnerabilities. You can start running your scan immediately, but it's only going to be able to report back the CVEs that it's already put inside the database itself. All right, let's go ahead and go back to the pipeline here for worker. So I kind of explained that YAML option. Again, my YAML is stored inside my version control system here. We have this Clair scan that's going to happen now. I've given it the image information, the tag information. It will connect to my Docker registry, pull down that image, create the scan. It's going to take and annotate my Docker image metadata, like you've seen that screenshot earlier. And then finally, it's going to generate a Clair report for me. So we're going to go ahead and execute this pipeline now. So I can just click the build button down here, select my branch, select my pipeline, and go ahead and build this. So once this build process completes, I'll be able to see both on my build a test report and also on the image some annotations. So we'll just give this here a second. And again, the check for Clair depends on how many vulnerabilities you have. Obviously, the larger your library, et cetera, the more vulnerabilities you're going to be exposed to. So it's going to take a lot longer, very similar to like if you were running a static code analysis. So depending on how many libraries you have, there's going to be more vulnerabilities that are possibly available, and that's going to take a little longer to report. On average, this takes about 2.5 minutes for this image. And then I have other images where it takes even longer, and I'll show you one of those later. There's an open source project for demo chat that we often use in demos. And it has a lot of vulnerabilities as well, and I'll show you that as another example of that Clair report. I'm trying to think if there's anything else I want to kind of cover at this time while we're waiting for this. I guess maybe something to talk about is this is just kind of one step in security, right? This is going to look at your libraries and dependencies, but there's still a couple other areas you might want to explore security around. There's your own code. So there is steps, like check marks, sneak, et cetera, that will do your static code analysis, where it will look at your code and not just the libraries and dependencies, but actual line by line through your code. So we provide some out of the box steps for that, and that will help you from preventing, basically doing exactly what these open source libraries are doing and introducing vulnerabilities into your own libraries that you've built from scratch. So it'll check through the lines of code for that. And the other is like an intrusion prevention. So as we're running our Docker images, there's companies out there like Twistlock, for example, that have runtime protection over our Docker images. So they are constantly monitoring the Docker containers that are running in our infrastructure. And they also constantly scan the Docker images running those containers and report that back, which I told you there is a notification option in Clair like that. But the really cool thing that they do, and I really like this, is that they watch for whenever that container's been breached. And they can shut down that container, making it very hard, like a moving target, for example, for the users to be able to kind of track down exactly, where this is at. The hacker itself, it's already gained access to that container. Twistlock can pick up that someone's in there running commands, running sudo commands, and tell you and alert you that somebody's in that container and actually, generating commands, which is often an attack vector when it comes to Docker images. But with Docker in containers in general, if you kind of hit that, close that port and open it up somewhere else, they're going to lose track of that container and they're going to lose access. And eventually they'll get bored. They're going to be in there for a little bit of time. That container is going to be spun down. And they're going to be like, okay, where'd my container go? And now they have to find a new container, and they really can't do any exploratory because they're always trying to hit this moving target, for example. All right, so this is done. That means we're going to have a build back here in our Codefresh system. You can see here we have a build, 2 minutes, 23 seconds. It generated about 3 minutes ago, and I have this test report available. Now, this test report really relies a lot on our storage integration. So we have an option to store reports in a lower formatting for multiple different reports from multiple different software testing suites. So I kind of consider this like one of those software testing suites, but we generate an HTML report here with this step. But back here, we have to actually set up, where we're going to store that. So we have an account settings integration here for cloud storage. So we can configure cloud storage for our accounts. And once that's configured with, basically probably a key and a secret, we're going to be able to utilize that and store all our build testing files inside of that. And there's a really great write-up in our documents page on how this works and how to set this up. And then, of course, there's just a simple step that I showed you. It's about 4 lines to be able to store this report inside of that. All right, so that's the integration page. Let's see what else I need to cover here. So the next thing is kind of like the aspect of the image itself with the annotation. So we can see here, here's our new worker image that we just did here. Our annotations are metadata that allows us to surface out the critical information from our build logs. The information surfaced from the Clair report step is going to be the Clair report here, and then information on the vulnerability count. So you can see here really quickly and identify, how many vulnerabilities we have. The highest one's going to be high. There's no critical here. So this information is really critical to our users to be able to get this. But as a security person, I may want to say, what is running in production? What do those vulnerabilities look like? And get that information in my hand. So by using the Kubernetes integration that we have with Codefresh, we can get that information into that user's hands. That user can come in here, and for example, I'm actually going to grab a completely different project. I'm going to grab this blue-green, which is our demo chat. Now, in here, you can see I have this demo chat deployed. This could be my development site. This could be my production site. It doesn't matter because we have traceability back to the image that was created inside of Codefresh. So in this traceability, you can see right here, I've actually been brought back to a Docker image metadata metadata information for that Docker image, and I can get the Clair report really quickly and easily. Now this one does take a second to load. It does have more vulnerabilities, so it's a little bit bigger. And like I said, with this report too, we can even only see the things that we can address right this second without having to contribute to the open source. Just packages we could try upgrading. We can look at, send that to the engineering team and get those upgrades fixed and ensure they're being fixed. So that kind of covers it. It is pretty quick. I knew I couldn't fill up the whole hour, so I think we're just going to kind of open it up to questions now. So, and here's question slide.
Awesome. Thank you, Dustin. Yeah, I remember when we were planning the webinar, you said, I don't know if I'm going to be able to fill up the whole hour because we've made it so simple. So that's a good reason why, because our plugin is so simple. So we also have Dan Garfield on the line. He's our chief evangelist at Codefresh. So Dan, you want to help facilitate some questions for us?
Yeah, so as you have some questions, feel free to add them into the Q&A button and we'll go through those. The first question that I see is how does Clair stack up against some of the paid solutions out there? I know that we've done webinars before on Sneak, on Twistlock, on X-Ray from JFrog. There are a lot of paid security scanning tools out there. Clair is obviously open source, it's free. How do they compare, or maybe we haven't done a comparison?
So I'm pretty familiar with Twistlock just because I have a pretty close relationship with them. The difference really between the two as far as just the scan and getting vulnerability information back in the report is that, vendors like Twistlock, and I'm sure there are other ones out there that are kind of similar in this nature, is they allow the security team a console to set up policies. So it's not just generated here for your engineers, it's actually getting sent up to another collection bucket. So there's a console sitting there that has the image information, and they can set up policies, really advanced policies around these different scans to help fail those. Another thing too, let me see, is that the vulnerability databases available for Clair are just the ones that the open source contributors have added. Like for example, Twistlock, I'm not even sure what the count is, but I know it's at least above 40 vulnerability databases that's available and always being imported. And I want to say last I checked, I think the count is less than 10 for the vulnerability databases being imported. If I was watching the logs on Clair, watching the vulnerability databases being imported, and there is a smaller selection. So, you know, if you're thinking about, is there vulnerability databases for Golang, Node, I forget the name of it, but there's all these different programming languages out there. Some of those won't be supported by Clair. So definitely check and take a look at the vulnerability libraries that are available for the Clair open source project before you kind of figure out if this is the right solution for you. You know, .NET Core definitely supported. Debbie and Jesse, for example, those operating systems that are bringing in packages, those are going to be supported. But you know, I'm not sure the full inclusive list, but this is where a vendor like Twistlock would really shine in giving you a lot of vulnerability database access.
Good. Okay, great. Yeah, great answer. So another question that we have here is there additional work to be done to keep the database up to date, just maintaining Clair? Does that have its own project, or can you create a pipeline that maintains it, or does it maintain itself? How does that work?
It's automated as part of Clair itself. So the Clair database, the databases get pulled on so two things, sorry. First thing is the databases that are already set up inside of Clair, those will update on like a nightly basis. I believe there's a cadence configuration that you can set to automate the updates there. But when you're talking about new vulnerability databases that are being introduced into Clair, because that does happen, that's how they start with the database. They say, here's the database. And also, too, there could be a point in time, I've been using it for a while now, there was a point in time where the vulnerability database actually changed from one location to another, so that URL had to be updated. And the way you take care of that is normally an update of the source code, which is where it's important to kind of get into that Helm installation, that chart update, etc., because you'll update that chart and you'll update the image tag that's used for that Clair image, and that's how you get the source code with the new vulnerability databases inside of it. You could definitely set up a pipeline around that too. You don't have to go through the manual install process. You could set up a pipeline and just pass in the particular image tag version you want to run and push that button. I'm trying to think if there's any way to, because there's no way to actually do any webhooks with open source projects, it would have to be still a manual button push, but you could definitely simplify it to just a button push with a variable, or you
like a cron job.
Yeah, or a cron job. There's a lot of different options available, but it's still, the cron job, you would have to put some coding around it to determine if this is the latest available. The good news is too, though, if you do automate something like that, every one of your Helm releases or upgrades, as we should call them, those are going to create a new revision in Codefresh. So if you do ever have a breaking change from that automation process where you're doing the updates to get the updates from the Docker image, we can roll back if something were to happen. So that's something that's supported inside of Codefresh and also Helm itself.
Another question we have here is, how can we speed up the image scanning process if there are multiple changes?
I'm not really sure. I need some clarification on that. When you say multiple changes, are you talking about like I guess, let me explain how the image scanning kind of works, right? So what it's going to do is it's going to grab your Docker image and it's going to pull apart all your different packages and libraries and dependencies and everything that's inside of that Docker image. So it's going to look for operating system vulnerabilities. It's going to look for like vulnerabilities with, say, if you're using like Node, with your Node modules, or, you know, if you're looking at like .NET Core, there's all those different packages you're bringing in from the internet. It's going to look at those. So there's really like no way to speed it up. It's really dependent on how big your microservice is. So if your microservice, as long as you made it a really portable microservice, which is really kind of the idea around microservices anyway, the image scan should be pretty big. But when you start getting into more of that monolith looking microservice, that's where you're going to have more libraries and dependencies being pulled in. So really the answer is, take a look at your application. If you're seeing a lot of vulnerabilities, maybe the application itself, that one particular Docker image for that microservice, maybe that microservice is too big. And maybe that needs to be split to be something that you can iterate on quicker, because that's going to help you speed up. If there's smaller number of packages for the operating system or for libraries, for dependencies, that's going to help speed up that process. And also you're going to minimize the cost to build and test as well if you start splitting those things out.
Very good. So another question, and this will probably be our final one, unless maybe one or two more. When it comes to, let's say you have a service that you only update every 6 months, even every year, a service that doesn't need a lot of maintenance, And this the thing that makes me think about this is Experian. They had a vulnerability that was a known bug that had been out for like 6 months. They hadn't patched their stuff. They hadn't updated it in that time, and so they were vulnerable. And so all of my data went out onto the internet, which was unfortunate. So how could you use this as part of existing services that you don't update that often to find out if they are vulnerable to the latest issues and vulnerabilities?
Well, there's two different things. One thing is that you can use this Docker image locally and initiate that scan. You can also use this Docker image from your machine to upload the Docker image into the Clair server itself. Then there's notification options you can set out to your team, and you can set that Docker image to be continually scanned, like on a daily basis for anything that you're going to push out there and kind of set and forget.
Inside of Clair or inside of Codefresh
So you can push from Codefresh for your project as far as the pipeline. The notification option is going to be set up inside of Clair itself. So it's going to hold the Docker image for you. It's going to pull it from the registry, hold the image, and continually scan it. But you can facilitate the action of being able to pull that image from there. So we put an entry point wrapper around what we have to allow you to just have a scanning service that you don't have to set a bunch of configuration options for. But there's also arguments you can set just to do things like upload your Docker image or anything like that would be supported by the PA Clair project, because that's where we based our scripting off of, is that Python package that's open source. So we have a lot of options available outside of just this default scan step that we set up an entry point around.
Yeah, a flow that came to mind for me thinking about that question was, what if, so getting an alert is one thing. Having that trigger a pipeline would probably be even better, right? A pipeline that actually automatically built it, sent it through the validation process, and then basically said, either automatically deployed it or said, hey, do you want to deploy this now that it's been patched? I think you could probably do that with the alert. You could probably set a webhook there that went to Codefresh. I'm not familiar enough with Clair to know the answer to that, but another option that
it generates an email. So if you have a system where you can receive emails and then generate webhooks, we do provide just simple webhooks to be able to orchestrate pipelines. So you have to parse that data.
That took the email.
That's exactly the vendor I was thinking of. So yeah, set up a Zapier to take the email. Probably you would want some sort of small payload inside the email that you could examine to determine what pipeline to run. And then inside of Codefresh, it's really simple. There is just a webhook available for all our pipelines. We don't have to install a CLI or orchestrate through the API. There's just a webhook URL.
Yeah, another thought that I had was I could set up basically a cron in Codefresh that ran once a week or even once a day that basically rescanned these things, and if it found new vulnerabilities, would then kick off the normal process and send an alert and maybe request an approval or something that would then get it going. Because I do think that is one part of this process that I know that organizations struggle with quite a bit, because if it's just part of their normal build and release process, you've eliminated a lot of issues. But if you don't release something to that service very often, it's very easy to let it get out of date. So I think that's an important thing.
Yeah, you can definitely scan this, and then with our notification options, we can send a Slack channel to an email address to let you know you have some failed builds that someone needs to look at.
Yeah,
they can examine it and examine the report and examine the vulnerability threshold that's been exceeded and determine what steps are next.
Great. Well, that's it for our questions today. So Dustin and Taryn, you can take us out.
Yes, so I went ahead and launched a poll. We really appreciate your feedback on our webinar. So please answer that poll for us and check out codefresh.io/events for our upcoming webinars. We have a webinar coming up in 2 weeks. We also post our meetups there. We're going to have a great post-KubeCon meetup if you're in the LA or San Francisco area. So thank you so much, Dustin. Make sure and go try out Codefresh. For 120 builds a month is our free account, and you can sign up on codefresh.io. We also offer one-on-ones with our DevOps experts if you want an individualized kind of consultation. So thank you so much. Dustin, thanks for joining us.
Bye.
Have a great day. Bye-bye.